advanced technology applications, Krish Corp, deep learning analytics, all people we work very closely with. They do great work in the area. In general, if your company is interested in being more connected into the community, come and email us, and we can form a partnership where we specifically route the types of people that you want to connect with to your organization. Right now, Booz Allen and O'Reilly have given us some money, so that way we can continue to function. Yay Booz, yay O'Reilly. If you're interested in helping us function, we're always looking for sponsors. Educational sponsors, District Data Labs. I know there's at least one person here from DDL, not from, but has taken their course. Anybody taken a course at DDL? 1, 2, right. Former president of Data Community organized that. Data Society does consulting and training. Statistics.com is all online. Get 15% off with their code. And of course, where are we? We're at Chief. Their motto is be brave. They are hiring all the time. I don't know if anybody from Chief wants to talk about what goes on here right now. This is your kind of chance to chat. Anyway, I can introduce you. They have lots of positions open. And I did kind of skip past this. I wanted to show you guys something cool that I've been doing recently. Not my email. This thing. Oh, that didn't work. So I'm just going to show you real quick. Who here did the survey on Invite when you RSVP? Right? A bunch of people. That's usually half of the people who actually did, because they want me to get on to the point, right? So I'm going to log in with Meetup here, and it's all local, but hopefully the Wi-Fi connection through Tony's thing lets me do this, because I haven't actually tested it there. And now it's waiting for my server. There it goes. Excellent. So now I'm logged in as me. And so what I've been wanting to solve for a long time is how do you choose what event you want to go to, right? And who should you talk to there? How many people here got into at least one conversation? Everybody should raise their hand. 2, 3, 4, 5. You were checking people in out front. That doesn't count.
I actually got into conversations with people besides that.
Oh, well, good. Excellent. This event is, there's about 60 people here. When there's 200 people, it's hard to know who to talk to, right? So we go and we choose an event, and, we can go through and which one should we choose? Well, let's choose the Women Data Scientist DC event. And it goes and it pulls all the people that are most connected at that event, and then you can go and explore. And look, we have the president of Data Community, Mandy Trod, and all the people that she's connected to. And the thickness of the line is just how connected you are to that person. So if you wanted to go through and explore who's at the event and how you're connected to them, this is something that I'm hoping to roll out in the next few months, and it'll be available for all the data community events. So that's kind of cool. That's something we do with full stack agents. If you're interested in working on that, you can always use some development help, so come and talk to me afterwards. And that said, there's Chief. Would anybody like to make an announcement? Talk about your jobs, talk about the training that you did, you went on vacation and you decided to measure the number of seashells on the beach. Announcements. Nothing? No announcements? There we go.
We're hiring.
There you go.
Thank you. I'm from FireEye, and it's a cybersecurity company in Reston. Okay, one branch is in Reston. So my team is hiring full stack and also front-end web app engineers. So if you like JavaScript, Ruby on Rails, Python, React, or Node.js, feel free to apply, and also go to FireEye's website and look at the career portion and see there are lots of job openings, but I'm just talking about these two, which is in my team. And I do data analysis, a lot of data analysis.
Tell them about how awesome it is to work at FireEye. Because if they want to find out about how to get in touch with
Yeah.
us, let them know.
Oh yeah, what I like is It's very autonomous. We don't get too much micromanaged, so it's more like talking to the people who are doing security analysis. Like they are trying to figure out if your system is hacked or not, and I'm making software for them. So there are not much middle management. It's like you talk to you're talking to the people who are using your software, and then you just go and build it. And we release every week, so it's like a continuous release, continuous development. And that's something I really, really like. And also everything is open source, so you get to choose what technology you're gonna use. Yeah.
Anybody else?
I can talk loudly enough. For those who are interested in Drupal, Drupal GovCon is going to be held this July 31st through April 2nd up at NIH, and we're going to be looking for speakers and opening for registration coming up in the next few weeks. If anybody's interested before then, come see me.
Anybody else? Okay. And I just love showing these things. I really should just take this out because it's so out of context at this point. Catherine Madden is so cool. And of course, afterwards, we go to data drinks. Google says you have to go around the block and through the circle, but I know a secret shortcut, and that's what the purple line is. So if you follow me, you get to walk, I don't know, 30 yards less. And our lineup tonight, Jason is a speaker, Awalin is a speaker. Why don't you guys go ahead and stand up. We've got Natasha and Erica in the back. We're going to go, we've been doing the data viz challenges, so each one of these speakers, except for our keynote, which is Awalin, they came in and had some sort of challenge. We brought in some people, they presented the challenge, we broke up into teams, we brought the results of those teams together, presented it, and then we all went and drank beer and ate food, which is the goal. So now they're today going to be presenting the results of them integrating this work into their companies. So we'll start in chronological order, and I'd like to bring up Jason Dalton.
All right, thank you, Sean. Yeah. So I'm from a company in Vienna, Virginia called Azimuth One, and we develop software for data analysis and data visualization for environmental contamination cleanup. And when Sean introduced me to this idea of having a mini hack for data viz, I knew exactly what I wanted to bring to the table. We had this one problem in our app that we've been going round and around with our designers, our dev team, with our customers to try to figure out a better, more intuitive way to display this one piece of information. And so I'm going to kind of walk through what we did that night and what we came up with and how the process went for me because I thought it was a pretty cool event. So here's our challenge. We have a laser? Nope. No laser. Use finger. So what we have is you have a three-dimensional volume, a large property that has environmental contamination in it. We know that there's contamination there. We don't really know the extent of it. We don't know the concentration. Sometimes we don't know what the makeup of it is, what the chemicals are that are down there. And so in order to discover these things, we do tests. And so we'll take soil samples, water samples. We'll push probes with direct sensing equipment on it. They can detect things like petroleum products and solvents and things like that. So that data is all represented along the bottom here. And so what this is displaying is what we call a transect or a cross section. So if you imagine walking across your backyard and every few feet, you push a probe into the ground. Each one of these vertical profiles would be one of those probes. And so as you're walking across your yard, you're taking what we call a transect. And so if you were to take a vertical slice down through that soil, this is what that slice represents, or is representing that slice. And there's lots of different data types in here, and I won't go into the details of what they all are, but these are, that look like time series kind of, are direct sensing data. We have soil types, which are along this column here, and these are our laboratory data. So when you take a soil sample and send it off to the lab, they'll come back and they'll say, we found 20 different chemicals, and these are the concentrations of those chemicals. So in this particular plot, we have, in pixel dimensions, we have X and Y location. We have height, we have width, we have color to work with in order to convey that information. And this particular plot here, which was the concentration of these chemicals, was always kind of lacking. It was one that the customers never really grabbed right away, never really understood. They could get these, they kind of understood these plots. The larger you got away from the axis, the higher the value, which is really the same down here, but because these are kind of blocks in space, it didn't really make sense. And so what we had done is taken the height of this block represents where that soil sample was taken. So there's a certain depth here, it looks like from 40 to 50 feet, let's say, there's a sample that's pulled out. And so that's representing the depth in the Z dimension. And then the X and Y position here, or sorry, the X position is the concentration. So the higher the concentration, the farther it is to the right. And the color represents what chemical compound it is. And we have a legend that has the names of all the compounds with the color associated with it. So if you know all that and you kind of internalized all that, you can figure out what's there, but it was never really all that good. Never really all that great. So I knew this was the problem that I wanted to bring to the table for the mini hack. And then, so when was it? About a month ago that we did the mini hack over at WeWork. And we had probably a dozen people or so come out to work on this. And it was just great. I mean, we had a lot of really good discussion. I did kind of a short session to teach people what we were dealing with, how to use the tools, provided some sample data. And then we broke up into teams, and each team worked on the problem for a little while we, myself and Anna, who's here tonight too, who works with me, we kind of went around and kind of explained, answered questions. So it went really well. There's a few, that's the example data we had. A few snapshots of the night. So because we were in kind of a shortened time horizon, and we didn't put any constraints on what people could do. I mean, it was basically, we described the problem and what physical constraints we had in terms of the dimensions of the screen and so forth. But really, from there, it was wide open. And so some people were hacking things together on their laptops. Some people were drawing things out literally on the back of a napkin. Some people went to whiteboards. We had lots of whiteboards around the room. And so it was a neat evening of kind of getting our brains going around this problem. So what we did was at the end, we had each of the teams present their work. And so they kind of went through their thought process, described what they thought was an improvement. And then what we could do was then take the best nuggets of those ideas across the entirety of the folks that were there that night and go back and put it together. And so we do a lot of our prototypes just on pen and paper. So we broke out the markers, and if you were to look at our GitHub issues, every one of them pretty much has a wireframe done up just like this, where we sketch it out first. And so we combined people's ideas to come up with a new design. And so that's what we see at the top here. And so the best sort of consensus design rotated the lab data 90 degrees so that instead of the vertical bar representing the depth, we represented the depth of the sample by this crosshatch here on the side at the axis. And then the bars are just a regular horizontal bar chart. And so we divide up the colors and the bars by the different compound types. A couple other ideas that came out of it as people were kind of thinking out of the box, putting the water level on there. So this blue line here is the groundwater, the depth to the groundwater at each of the station locations. And when we roll over, this is a paper cutout of what would happen if you hover your mouse over it. So when you hover your mouse over it, you get a little table that describes what the concentration limit is at that location. And the ones that are highlighted in yellow are ones that are above the government mandated regulation for concentration values. So anything that has this yellow hash mark here or is yellow in this table here is important to take note of. It's where we've gone above our, essentially our control limits on what we can tolerate in the soil. So we started to implement this. We shipped this around to some of our customers to get feedback. We've already implemented the water line. That was an obvious one that we wanted to include, and we're starting to develop this as well into a version that we can ship out into our product. But, yeah, so if you're ever are thinking about doing a mini hack, I would definitely recommend taking folks up on it. And then we took everybody out for food and drinks at the end of the night, and good time was had by all.
Awesome little round of applause. Questions?
Yeah.
They can't hear you back.
Sorry. What type of tools people use for the hackathon? Did they like code everything from scratch, or did they use some sort of like
We use the
third-party tools?
neuroplastic interface in order to automatically code things based on people's inner id. You ever see the Forbidden Planet? Where
It's a 1950s movie,
they
right?
just hook up an advanced system to their mind and
Oh,
the code
like a
drops
brain
out
computer.
automatically. We use whiteboards.
Oh, okay.
I'm sarcastic, I'm sorry, I'm a goofball.
Yeah.
We would love to be able to code, but honestly, getting that done in an hour or two, in 2 to 3 hours, along with understanding the challenge and then deciding things in teams is pretty monumental task.
I wanted to do something with hackathon, this one.
Yes.
I thought, oh my god, it's only 1 hour, I cannot probably run anything. But now I'm inspired. Like,
Okay. Yeah, next time come on out. 'Cause we definitely wanted people to throw their ideas up on the board and not worry about getting bogged down in the code that was going.
Hi there. Did you consider doing a stacked bar chart or maybe a circle with the different colors, like concentric circles, as a representation visually?
We had a circle-like chart at one point called a nightingale chart, if you know that one. So that's one that we've experimented with. The stacked bar chart, because these concentrations don't necessarily equate across compounds, so 2 parts per billion of benzene may not be the same toxicity as 2 parts per billion of trichloroethylene. Right? So they don't really stack to equal some total contaminant level. It's really an individual thing. So we wouldn't stack them in that way, I don't think. But both of those did cross our paths. Yeah. Yes.
Hi, I think this is really neat. I'm just wondering, when you build it out, have you been thinking about time so that you'd be able to see the change over time and clean up?
Yeah, absolutely. In fact, another iteration of this is one where this is a time series here, and each of the contaminants is a point along that time series. Yeah. Yeah. Next steps. Yeah.
I'm remembering this, and I'm remembering the videos that came out. I'm trying to remember how this came out of what we put together.
There was one team that recommended indicating where the limits were.
Mhm.
There was another team that recommended rotating it sideways,
Mhm.
and there's a third team that recommended the water level. So we wrapped all of those together took the best of each of them.
Awesome. And that's the whole point, right? It's
Yeah.
just inspire ideas to get you thinking, not necessarily to provide an answer.
Right.
And it's certainly not working code that is bulletproof and tested and QA'd and all that stuff. All right, one last round of applause. And next in the timeline would be Erica, right? Yes. Erica is filling in for Amy Dawson from Bob Woodward Foundation. Couldn't make it today. She is up in New York. But thankfully, Erica was kind enough to come and fill in. And we got to hook up her laptop, so please hold on a second.
Tony is doing magic things to hook up my laptop right now from live connection.
There we go, it's starting to work. So what's interesting here is that we're actually getting a presentation before we do a Viz challenge. So we'll be doing this visualization challenge on April 2nd or 3rd, maybe the 4th. I haven't secured the venue yet, but it'll be one of those 3 days. And so this, as you're listening to this presentation, she's going to be leading another effort in about a month to improve upon what's being presented. So without further ado.
All right, thanks, John. So what I'm going to talk to you today about is a project I've been working for a while. It's called Web Historian. And I'm going to start off with the motivation behind the project so you get a sense of what I'm trying to accomplish. So you might know that people don't read terms of service. And this is a big issue when you're talking about agreeing to participate in research, because social scientists want to use trace data, and we're sort of live in this world where people don't read terms of service, and some people want to blame individuals for that. I don't think that should be the case. If there was a study done about if you read all of the terms of service and privacy policies of all the technologies you use, spend several hours a day doing that, so that's not how I want to spend my day. So the system is basically broken in this regard. And so what I want to do is just sort of, I can't fix that entire system, but within my own little corner of the world, I want to do what I can to resist that temptation to get people to give you data that they don't understand what they're giving you, right? So I'm a social scientist. I'm in the School of Communication at American University, and I think it's really important that in social science we use digital trace data, like web browsing data, which I'll talk about today, for social scientific purposes. I think that to study our world today, that's what we need to do. And I think there are ways that we can do it that actually involve informed consent. So the idea is to sort of not contribute to a system that I believe doesn't work very well. And the concept that I'm using is called trace partnership. So that's sort of partnering with users through informed consent to enable research with digital traces in social sciences. And so there's practical reasons for this as well, right? People don't like being tricked and giving you things that they don't know that they're giving you. So it's a normative stance, and it's also a practical stance that if people see social scientists as just another person trying to steal my data, that situation can't last forever. So I also thought these musical notes were a nice little visualization here too. Okay, so the goal is to use data visualization to vastly improve informed consent. I don't know how many of you are familiar with the IRB process. Anybody? Yeah, several. Yeah. So that's the institutional review board that you go through to do university research, and you will get these sort of standardized informed consent templates that some people read, but not very many. And even if you gave it to them, it's not quite the same as showing them the data that you actually want to get. So if anybody wants to try out the visualizations I'm going to show you, that's the URL where you can get the Chrome extension, if you would like. So this is a standard informed consent form. It looks a lot like a terms of service agreement or something else, which is just sort of mandated to use. Now, I can't change the entire informed consent regime, but I think it is materially different if you're asking somebody to give you their web browsing data than if you're asking them to take a survey. People have a much better sense of what they're giving you if they're answering survey questions. Not perfect, but a lot better than if you're asking for web browsing data. And this is the only way that they've seen it before. So what I want to do is show you a little video quickly of the current software. And I'll just run through the features very quickly. I will start off by this. Okay. So these are D3 visualizations. This is a network of how you get to where you're going. You see Google in the center there. You'll see Facebook over here. When you right-click, you get a menu where you can delete whatever you want, and you can also go to the data table where you can see all of the underlying data that is underneath this. You can also choose to remove specific visits or entire domains. I'm not aware of any other extension that lets you remove entire domains. This is the web visits view. You can see which sites you visit, how much you visit them. There's also a couple other visualizations, including the time heat map. So this is just the time that you visit Google Docs, but you can see that how the time signature differs for different sites. This is the search words. These are the words that you use in multiple different search terms that are larger, and the actual terms are shown when you hover over them. And this is going back to the web visits. You can highlight particular items. This is 1 week of data. You have 90 days here. This is the habits view where it's 1 per day. So these are only 7 times larger than this here. But we're going to go out to 90, and this shows a pretty good view of the sites that I tend to visit a lot personally. This is all my own data. So that was a lot of information really quickly. And I have the extension open for if we have any time for questions. But I did want to quickly go back here and conclude that really this way of visualizing web browsing information is already a big improvement over an informed consent form. It could certainly be improved in a lot of ways, and I'm very much looking for suggestions. The tool is useful for a number of other purposes. If you want to interview people about what they've actually done on the web, It's much more useful if they can see what they've done on the web than just asking them about it. It's a very habitual kind of thing, and so you can get a much better interview about what people are doing online. And then, of course, personal time management is another potential use for this. And also, for research participants who want to upload their data to a server after they've cleaned it and agreed to do so, you can also compare your data across browsers, upload multiple browsers, and compare yourself to other users in different groups. So the main point is that it's really important to develop open source tools to enable this kind of approach to gathering data. It offers a number of benefits. It's replicable, which APIs are only replicable until the company decides to change the API. Same thing with panels. They don't tell you how they do anything in the first place. It also promotes academic freedom. If you partner with a company to get trace data, you have to play by their rules. And it also promotes public education of the kind of data that's out there that is now freely being sold to whoever wants it by your ISP, as we know as of last week, right? And you should at least know what's there. And it's a way to resist the broken privacy self-management system that we have. So that is what I have for you.
Would you mind going back to what you consider the visualization challenge to be, and just stating that explicitly?
Yes, absolutely. So let me go see. So we have the actual visualization itself. I think that while the network visualization is super cool, people don't understand what it is. So that's a challenge. If there's any ways to sort of make that more intuitive of what this means, right? So Google is going to be in the center for a lot of people, but it's Facebook for young people.
And this is showing their history on the web.
This is showing which sites link to other sites, and so it has a directional. So I went from Google to consumerist in this case, right?
So this is your history,
This is mine.
and then how it's all linked together.
Yes. So it's sort of showing who controls my view of the web, right? So, more centralized view means I only go to Google or I only go to Facebook, and more spread out means I have a lot of different sources of information. So that's one challenge. And then another one with the web visits, I think this visual is prettier, but I think this one is more informative. So that's another challenge. When you go out here, it's somewhat also okay. But it's basically, so what the current plan is to do this month is to break this one giant extension into smaller pieces. Because basically each one of these visualizations in the navigation can stand on its own as an extension. And I think it would be more straightforward to tell people what it's about if I say, this is a search terms extension, download it, rather than this is everything you do with your web browser.
Like a more focused purpose, so the expectations are set.
Yes, and separating out the research project as a separate extension and having the other ones sort of recommend the research extension separately. So that's another thing. Yes.
Right behind you, sir.
Did you consider visualizing different devices differently, or does this combine all of the history across devices?
Yeah, so this currently, as a Chrome extension, the way that it gets the data is only from the Chrome browser. You can import data from Internet Explorer and Firefox into Chrome, but it would show it all the same. But on the server, you can upload from different devices and show it either separately or together. Yeah, And so in terms of next steps are mobile. As you may know, you don't use your mobile device browser the same as you use your desktop browser. So if you go to Facebook on your mobile, you're going to go to a separate app. Whereas if you go on a browser, you're going to go into a browser. And so that presents a challenge that the data is not exactly the same across platforms. So there's a lot of challenges with that. But it's exciting.
When I looked at your graph visualization, I started thinking about some of the security implications, like some of the work that you do. You had the central tendency of Google, I think, where they mostly start and branch off from there, but there were these swimmers on the outside.
Yes.
They were probably like inbound marketing or phishing attempts or something like that, where it's just a random link that comes in. Like those guys that are just onesie twosies up to the outside.
Yeah, so this is not the browsing history doesn't have, it only gets pages that you can use the back button to get to. It doesn't suck in everything that you download. So these are all websites that I visited, not things that were ancillarily downloaded in the background that I didn't know about.
Yeah, a link that you followed.
A link that I followed, yes.
Another quick question, does this separate out by users? I'm just curious, in the browser, are you getting all that browser activity?
User in the browser, yes. So if people use that feature, it would only get from the user.
Another question, I'm not sure, have you actually tried to shop this with your IRB in terms of helping instruct people? What was their reception of it?
Well, it was good in that it was sort of in addition to the standard form. So I use the form as well. So when you participate in the research project, it sends you to a form and a survey, which is sort of their standard protocol as well. But yes, so it's sort of a both and rather than an either or situation at this point.
And they expect you to then use this as a demo every time you do the informed consent process as to how to help people appreciate what their browsing history is or what they're consenting to, I guess, in that.
They are a little bit less technologically sophisticated than that, but yes, essentially. The process is that this is sort of before you consent to the research process, you explore your data in some way, and then you upload, right? Is there anything, mechanism sort of forcing you to do that? No.
Right, okay, thanks.
Do you have regard how long people?
How long people stay in one website?
That's not in the history. What I have is you visit one site, then you visit another site. I don't know if you then came back to that first site and viewed it more, or if you went to go to walk your dog or whatever.
Do you have a dog?
In future versions, I'll have a little bit better measure of that because this is going to the past only with the history, but if you use it on an ongoing basis, when you go towards the future, you can get a sense of which tabs are open and that sort of thing to get a better sense of flow.
I just want to know like how much time I waste on Facebook. Oh no, sorry, not waste. Invest on Facebook.
Yes.
So,
Yeah. I mean, you can get a sense of when you use Facebook, and you can also get a sense of how much compared to other websites you use it. So, so yeah, you can, in this case, I'm here. And then you can see, which, what exactly it is. You can also see, what time of day, things like that. And you can actually break it down below the Facebook level. You'll see here in the URLs. So if you're just looking at the news feed, it's just the same URL, but if you're looking at a particular group, right, this is my group for my class, it has a separate URL, and you can actually break that out a little bit further.
One last round of applause.
you will be participating at the
We just recently did the NeuroBiz event that was last week over at Verizon, and that was with Sarah Kimmich, and Natasha here has been working with Sarah, and Sarah is, well, she's out in California somewhere, right? And but we're all part of this, and I'm happy to introduce Natasha from NIH.
Yeah, hi. So, as you said, I work with Sarah at the National Institute of Mental Health, and we work in a section called the Section on Functional Imaging Methods, and basically, as you can probably infer, we're using different types of imaging methods to try to improve mental health outcomes. And Sarah is particularly interested in this type of therapy called neurofeedback. So, I don't know how many of you have heard of neurofeedback, but But neurofeedback is a technique that can be used to regulate a specific area or network of areas in the brain by providing sensory feedback to the subject. And how it works is that you use some kind of imaging method. I'll go into what type of imaging method we use to target a particular region of the brain. And when activity changes in that are detected in that area, you specifically will set a threshold activity level in your area, whether it's increasing or decreasing by using rate of change. You provide some kind of feedback to the person to let them know that that is the right type of brain activity we're looking for, and to help them learn and upregulate that activity. And so, for an example, one of the most common areas neurofeedback is used in is in ADHD, where they'll try to upregulate attention networks. But one of the interesting things about this is that they don't tell you, we want you to try to use your attention network, or if it was used in depression, we don't want you to try to be happy. They just give them a puzzle or some kind of task and are asked to figure it out on their own, kind of subconsciously. So, the method we use is called real-time functional magnetic resonance imaging, or fMRI. And what the people do is they're put in a scanner, in an MRI scanner, and we image their brain and give them some type of visual stimulus, or we could give them an auditory stimulus, and measure their brain activity. And then the brain activity goes through our computer system and puts back out a type of stimulus for them to look at. There is a processing delay of about 2 seconds from the time that they see the stimulus, from the time we detect the activity to the time they see the stimulus. And so that's one of the challenges we're trying to address. And then the other thing we have to consider is that conscious perception is about 20 to 50 milliseconds after the stimulus, and it lasts for at least 40 milliseconds. Okay. Oh. No. Uh-oh.
Oh, is Microsoft trying to help with them?
Okay, well, it's still here, so we're good. Yeah, I'm good. Huh. Well, my slides disappeared, but that's okay. All right, so we have two main challenges. The first challenge is to try to come up with the best ways to detect the brain activity and detect it quickly, and the second challenge is to come up with good stimuli for the participant to know that they're doing the good feedback, I guess, for them to know what's going on. So the feedback we currently use, we have two different examples, and I'm going to show you the one we are using right now. This is the challenge we came with to the data hack for, the biz hack. And so currently we have this puzzle, and we say, okay, we want you to try to reveal the puzzle with your brain. And that's all they're doing. And then this is in real time what it normally would look like. And somehow, it just starts showing up, because your brain naturally goes through all these different states. And as it figures it out, it starts to go faster and faster until it reveals an entire picture. But we wanted something that's a little more engaging and interesting. Because when you're learning something, you're more likely to learn, if you're really excited and engaged about the task. One of the analogies a lot of people use is that when you're trying to teach a monkey something, the monkey's not going to learn unless they're really engaged, and so they often use food. They press the right button, they get food. We're not going to give people food in a scanner, so we try to use these, and we couldn't do that time-wise, but we use these type of picture stimuli. But we want things that are more interesting for a viewer. So the even older one was worse. It was just a little thermometer, and every time your brain activity went up, you get another step up on the ladder. Here are a few more examples. Here's one they used for a smoking cessation video. Your brain activity goes up and up and up and up and up, and then you get a smiley face. So we came up with this challenge, and we said we want to have clear and observable progression. It doesn't include outward attention networks. We don't want social stimuli, and giving some kind of aha moment. Predictable but satisfying for the viewer. So, now I'm going to go to our... Oh, right. You did say that. 4 fingers.
There you go.
Okay. So I already mentioned why we hacked. We want to come up with better stimuli for the viewer to know what's going on. And what we learned was that the most compelling neurofeedback stimuli started simple and got more and complex over time, like a slowly budding tree, or a piece of flat paper that folded into origami, or the gradual arrangement of classical instruments into a soundscape if we were going to use sound. Simple but compelling. So we had lots of different ideas. We had, like I said, the tree, these changing budding colors. Here we have an example of a orchestra, and I think this link is available as well to anyone to look at. Snowflake progressions, and also telling a story. So you have a little person, and every time the activity is shown, they move along a little landscape and see a rabbit or a tree, and something happens. I'm going to show you an example of one of the ones we thought was one of the most interesting, and it could be really valuable. So you can see this is slowly going up, and we would have it go in little segments of our 2 seconds, and it would stop or slow down based on our imaging data.
So talk about that. Like, it would stop or slow down based on...
So if we had our network of brain areas, and so suppose we had 3 areas we were looking at, and we wanted 2 of them to go up, 1 of them to go down. And when we saw that network and it had the right detection level, we would have this start moving. And then, but if we didn't have the activation level, it wouldn't move. There's some more variations. And it could slow down, and we could change the colors and do all sorts of different variations on this. There's a good one at the bottom here. sorts of variations, lots of things to think about. This was just last week, so we haven't had less than a week ago too much time to look into all of them, but there are a lot of really great codes out there that can generate random associations. This one's a pretty one. Colors it. These color very quickly, but you can change the time and
Round of applause.
Now, if you all understood that the first time around, you each deserve a PhD. Any questions?
Yep. Right behind you.
First of all, great work. I have 3 questions.
Oh boy.
Okay, so coming from a clinical perspective, there are causation effects, right? When you try to analyze the problem in a brain, right? Every brain is a cell and mutations. I'm not going in even in genetics. Say for example, a person has risk factors like PTSD, traumatic brain injury and things like that. That's called a causation effect. So when you have person have diabetes, I'm just giving an example. One leads to diabetes plus high blood pressure leads to stroke, right? So you have a causation effects on that. So that's one question. You take causation into consideration. Second is when you talk about these images, are you talking about diagram images and doing analysis on that? Are you plan to use some techniques like artificial intelligence and neural networks, which is actually unveiling the brain networks?
Did you have one more question? Okay. So we are, as for the causation effects, we can't really say for sure whether it's causation. We are primarily looking at correlation effects because, so we'll do these brain activity. We detect the brain activity, so we're using real, I'll start with your second question, and then I think it'll flow more easily into your next question. We use real-time feedback, and yes, they are DICOM images, but they're images that come right out of the scanner immediately. And we have a code that automatically translates the image or the detection of the activity within 2 seconds and can convert it into an image for the viewer to see. But the effects that we find, we can't say if they're causation because they're in humans. It's completely non-invasive. We are just detecting feedback and giving the viewer an image to look at. It's all going on in their brain. We do behavioral tests with them after to see if their symptoms improved after these, and for a lot of these studies it has, which has been very perplexing to a lot of people. But we can't say it's causation, although we hope it would be.
Thank you. Maybe we can do.
Yeah,
I work for Veterans Affairs, so we do a lot of projects for PTSD and TBI and things like that.
Yeah.
Talk to each other.
Also, this is Sarah's project. I work with her, but she knows a lot more than me. I'm very, very new to the field.
Thank you.
But she would be happy to talk to you as well.
Doing an excellent job representing. Any other questions? I have questions, but I guess it's I'll save it for the bar afterwards. One more round of applause. And last but not least, we have Awalin Sopan, and pull up that information. Which one is? I don't know. It's the number 3. Yes. And, do you want to drive, or you want me to drive? Okay. And, you are.
Hello. Thank you. Thank you, Data Community DC, for this meetup, and this is a wonderful place. I don't know if you guys know this, I was eating pizza and I almost forgot that there is a meetup going on this service out there. Anyways, about me. I'm a software engineer. I'm working in FireEye, and FireEye's software as a service division. So what my team does is basically we have clients from all over the world, and instead of having their own security team, they will basically give us all of their data, access to all of their network, and our security team or our security analyst, they will monitor that data and figure it out if there's any threat in their system or not. And usually the security operation control room or SOC, what they do is they use several different kinds of software to detect or prevent threat in your network. And what we are trying to do and what we are doing is making a unified software for them. So rather than moving through like, hey, use this software to analyze the network content and this other software to do the network visualization, and that another thing to do like, oh, this is to see the malware, we are trying to make them one unified interface. So the analyst will just use that one interface rather than moving from one place to another, and they can concentrate better this way. So my team builds that product, and it's awesome. And in the back end, we're also doing a lot of decision trees and machine learning stuff, so they know what to do. So when I was in school, I thought when I grow up, I will like save the environment or do something about health. And I thought cybersecurity is boring. But it's not, because now you see like after all those like hack or Russian hack, all those hacks, like it's actually very, very, very important. And this is a quote from Obama from 2009, like how he was very concerned about like creating cybersecurity as a national challenge, so people will actually be very careful about it. So this is also a report from our company where they say like, okay, what are the industry that's being hacked the most? And 17%, you can see like this. Do you see my mouse? No? Oh. Do you see the mouse pointer? Okay, great. Yeah, so most of them are business and industries because yeah, like credit card, all those type of hack, but it's not only that, like retail, finance, that's okay. Okay, not okay, but again, like there are legal services and healthcare, those are also hacked. So it's not just you're losing your money, you're losing your personal information, so that's pretty serious. Just to give an introduction, it's basically a life cycle of a cyber attack, like usually what's happening beyond just regular phishing attack. Say a bad person or a hacker, they will try to create an initial exploitation of your system. So they will not immediately hack your system, but they will just try to create a connection. And later they will try to alleviate their access control. So first they will just access your system and they will not do anything for a long time. And gradually they will try to establish a control over your system. And finally, when they compromise your system, like it's been too long, you probably have no idea that they have been in your system for that long. And these are basically called advanced persistent threat because they're in your system and you don't know about it. And it's difficult to understand that they are in your system. So definitely these are advanced things, like the hackers are always way ahead of us, so you cannot just use machine learning all the time to understand like, oh, I think like, oh, I run some deep neural network algorithm and say like, oh, it looks like an attack. Because there are lots of different new data coming all over every day, so you need like humans sitting around and looking at your data to understand whether it's an attack or not. So in this case, like both machine and human, they're working together. And the analysts, what they do is they look at your network and they look at your computer and the system logs, all those things, and try to see like if it's an attack or not, so they can detect the intrusion and they can also prevent the intrusion. So it's say before your system is hacked, they can say like, oh yeah, it looks like someone's trying to compromise your system, so basically you have to quarantine your computer or your system will going to be compromised if you don't do this. And the last one is forensic analysis, like, okay, you are already hacked, like the Sony was hacked, like Sony Enterprise, that you see like lots of movie got leaked, etc., etc. So in that case, like, okay, there's nothing else to do, you already lost all of your information, what can you do? What you can do is the analyst will look at your system and they will trace back the log and say like, oh yeah, I think there's a pattern, so next time you see this pattern, it must be a hack. So they try to do some forensic analysis to understand like what actually happened, like how they gain access to your system. So now come to the point, I'm talking about data visualization. So when it comes to data visualization, let's look at like what are the data we're talking about. So in security data, like the data that analysts are looking at, it comes from various sensors from the network. This one, it can be multivariate data, like the packet that we are capturing packet from the network, the IP, the port, the size of the packet, the time, also the content. Another can be different sorts of logs, like it can be system logs or logs from the server, logs from the firewall. So firewall. So basically everything happened in your system, there is a log. You can basically write down everything in a log, and then later you can analyze what's happened to your system. This one is just system log from my laptop because I wasn't allowed to show anything else. So this is basically my computer. You can run the same query and see what's happening to your system, and you'll see like lots of Google. Then again, there will be security data can be relational. So flow data, for example, flow data, like you have network packet coming from one IP to your IP. Same thing, like flow can be going through your router. And this is basically a very good source of information, like if someone is trying to attack your system or not. That's also a nested query running in my machine. So you see like this is my local address and those are all the foreign IP that's communicating an established connection in my IP. So you can run also nested command and see like all the IPs that are trying to connect. So you see like this is very boring, like it's basically a command prompt, and then you can make it less boring to copy paste it in Microsoft Excel. Still not very helpful. So, but again, like even few years back, all the analysts did is like use Microsoft Excel and try to figure out like, oh yeah, I see that there are like, oh, lots of same IP and then some different IP, again the same IP, but like do you even get the connection, like what's actually happening? Or even like, oh, I see like lots of 445 ports, but what's actually happening, I don't know. Another thing is like, okay, so this is the IP like 101, and it's connecting with another IP 10 at this time. So when it was connecting or talking to that other IP, what was the data? Like what was the data that it was trying to reach or trying to get? So then you can also get this data packet from the flow. So okay, so IP 101 talked to IP 10, and this was their communication. So basically it's a binary file. And then you can download it in your system, and from the binary you get this hexadecimal value, and then you can convert it to ASCII, and you're like, oh, I see something interesting. Like you can do Control F and see there's like something interesting or not. So oh yeah, there's like thing called user agent, so maybe it's interesting, maybe it's not, but since there are lots of ASCII code or even readable thing, you can make, okay, keep reading and trying to understand what's happening. So maybe it's a hack, maybe it's not, maybe they're trying to install a malicious code in your system. But again, like it's very manual. I would not want that job where I have to read through this all the time. And for temporal data, basically any data with temporal information, if you have the information of time, you want to see like what happened over time, then you just analyze with like time series visualization, this type of thing. I think Jason already mentioned that there was like a time component in your hackathon too. So while analysts are using all those tools and the software trying to read, definitely, I mean, it's a data community, data visualization community, but I still have this slide to explain like why we need visualization, because you can communicate our findings, like just create a report and give it to your manager, or like get an overview of what's happening in your system. Again, you can analyze, you can compare, like, okay, this is my network looked like yesterday, this is how it looks today. Is this same, is this normal, or do I need to look more carefully and like find a trend, find a pattern? Another thing is predictive analytics, like if the network is like getting very, very, very busy, maybe it's a sign of something or not. And definitely finding an anomaly if you're comparing, like, oh, someone is trying to log into my machine at 12 a.m. at night, like, why would someone do that? And visual analytics is beyond data visualization, so you're not just presenting the data in a visualization in a chart, you are also giving the users an ability to interact with the system. So they can understand the system and they can make better decisions. And I definitely have to quote my advisor, which was like, how do you proceed with visual analytics? So first, his idea was like first see the overview. So give the user an overview of the system. For example, in Jason's visualization, you saw like there was like overview of all the different segments. And then if you click, you might be able to see like more details. And then zoom and filter. So you can zoom any interesting area, like, oh yeah, this looks weird, like why is the soil sample very weird in this particular case? Or you can filter with time, like I'm only interested what happened in the month of May or the month of June. So this way you can also filter. And again, like details on demand. So there are different ways you can use data visualization to help with your analysis. So I talked about the data, different types of data. Now let's see like how we can convert them into different types of visualization. Like this is also like very basic, but I'm just gonna do it anyway. So when it comes to multivariate data, like the basic thing comes to your mind is a table. Like there's always a table. Even if you don't think it's useful, it's just good to have a table, so you can always like Control F and find things, and later you can make scatter plot, bubble chart, parallel coordinate. And for relational data, yes, like node link diagram, you saw like in the web historian project, like how you are showing the links using a node link diagram and force-directed layout. But if it's hierarchical, if you have like a parent-child relationship, tree map is a very nice way to represent that data. And for temporal data or the event log that we find from the servers, it's very important to see like the trend and how the events are happening. So in that case, it's good to see the time and the timeline, like a history, like, oh yeah, this file was installed in my system and then it tried to access my database, like let's see all those events in a timeline to understand. I'll start with an example, and this was from VAST 2012 mini challenge. It's available on the VAST 2012 website. I think you can all just freely download this data. I think they have like 6,000 rows. It looked exactly like, where is that? That Excel sheet that I showed. Yeah, it's basically a screenshot from that. So it has different nodes or different IPs and their communication. So once I draw the network visualization using node link diagram, and it's using the force-directed layout, you immediately see there's two communities, there are two components. One is this crazy hairball component, another one is like very, very well defined, like one big node and like lots of other IPs talking to this. And in this case, all I did is just size the IP based on how many connections it's getting. So you can clearly see that this huge hairball, no node, no particular IP is getting too many connections, but it's also very well connected. Whereas this one particular IP is getting bombarded by a lot of different IPs. So what's happening?
Is that Google?
No, it's artificially created data by the vast community, so it's not Google. But they're saying like it's an IP, it's like some server in your system or in your organization. Just to make it clear, I used the label and then I realized, oh, at this moment I don't need the labels, so no labels. Then I realized like, okay, let's color it. So I sized the nodes at first, and now I'm coloring the connection. So green means like these two nodes kind of communicated a lot of time. And red means these two nodes didn't communicate that many times. Maybe there was just one packet sent and they stopped. But green is like they're trying to hammer this IP a lot of times. So here you see like mostly these are green, and here mostly these are red. And I filtered them. I filtered as in I only have like top 25% strong communication link. So say I talked with you 10 times and I talked with you like 2 times. I discarded the smaller communications. So I'm trying to see like which part of network is very strong. So again, like this was at 25, it's still not very clear, so then I keep only top 10% communication. Now it's like getting more clearer. You see like which IPs are talking a lot among themselves, but it's still like red and this is still green. Here's some other green, that means like they're also very stronger communication. And I decided to use color instead of size because if you are sizing the edge, they become like very fat and it's just all over, you cannot see anything. Then I said, okay, let's have only top 5% stronger communication. And you see like the other network is totally bound. And this is that IP that's getting like requests from lots of other IPs. So in security aspect, this does look like a distributed DOS attack, which is like everyone is trying to access your system and you are basically blocked. Like you cannot do anything because you're getting so many requests from different IPs. So what they want to do is like the hacker will request so many, they will send so many requests in your system, you cannot do anything, and the real user cannot access your system. So if you're a bank account or if you're, like financial service and your system is down, it can cause a lot of problem in your system. So it does look like a distributed DOS attack or denial of service attack. But say you are an analyst and you want to be very clear and very sure, like, hey, is this what's happening? So you analyze the flows, now you want to analyze the content, like, okay, now let me see like what data they're sending. So you write a rule, like every time, your rule is like every time someone sends me a request which has these words like user agent, displayed by the way, user agent, logo, Mozilla, Rabbit, all of those, I would think like it's an attack, like they're trying to have a malicious attack in my system, they're trying to kill me or steal my information. So this is the rule, and you already make a rule, you write a code that every time a packet comes, your sensor will try to like sniff. It's like, is it that, is it good, like does it match with this? And this is one of those example packet. So say you don't use any visualization or anything, but you know this is the rule, what will you do? You will do a Control F with all those, like, hey, I do Control F and see like if user agent is present here or not. And why would you make someone do this? So what we did is, so that's one problem, like you have to do manually. Another problem is those rules. Those are proprietary information in your company, so you cannot just use a third-party software and say, like, hey, match it with my network packet. You cannot do that. So what you can easily do is, like, here's your rule, here's the network packet, and you can just clearly show them whether it matches or not. So when you are an analyst, you are trying to understand whether it's a malicious attack or not. You don't actually have to read and like do Control F, all of those things. The rule is here, the matching is here, and it's not even like huge data visualization. It's like very simple, minimal visual clue, but it's giving them a lot of confidence about the rules they wrote, and it's also saving a lot of time. And basically this feature that we built, it was very well accepted by our security analysts. They're like, oh, it saves a lot of time. We don't have to go to Wireshark and then analyze our PCAP, and we don't have to go through like, oh, if it matches our rule or not. So once you analyze those packets, you can see, you can like label different packets based on like whether it's malicious or not. So we did already the network analysis. Now I want to do the packet analysis or the content analysis. And we label the packet based on like whether it's a bad or not, like what type of behavior, what type of category. So this one, yes. So this is a tree map with the hierarchy, and what I did is like the top level is the category. So we have 3 categories. One is attempted information leak based on those packet analysis, and another one is just potentially bad traffic. Another one is just like corporate privacy violation. And you see the size and the color is based on like how many times those IP was accessed. So this is the target IP, 01, this is 10, and those are the source IPs. So those IPs trying to access my target IPs. And there comes the interesting point, you see. This 010, this one was the IP in the center. It looked like lots of other IPs are trying to access it. But the content matching says that it's just a simple corporate policy violation. All those packets, they're just like not doing much harm. On the other hand, like 0.1, this one actually is more susceptible to attack. Like all those packets, they're trying to attempt like information leak, and they were actually bad traffic. So now I go back to the network again. So this is the part where the actual hacking is happening. And this is more like a decoy. So I try to write like fake news here, but then I realize it's not actually fake news. It's the news that distracts you when the real thing is happening on the behind, and you are like, oh, I don't care, like, but it's not. Like, you are so concentrated. Like, sometimes hackers will do that. They will try to compromise one part of your system, and you will be like, oh my god, it's so much problem happening there, let me go fix it. But on the other time, like, here only like 5 IPs are attacking this, but they're actually trying to compromise your system. They're actually trying to leak your data. So that was all from like content analysis and the network analysis. And you can do it easily using this data visualization instead of going through like reading the packets and basically going through Excel sheet. No offense to Excel. And again, for cyber analysts, port is also very important because different data comes through different ports. Like for email, we use one port. For authorization or security, there's another port. So they're also wanting to see like which port is the data coming from. So you see, this is this one, the target IP. So the IP that was attacked, it's been attacked in different ports. On the other hand, the source IP, all the attacks are coming from one port. So they don't care, they just want to send all the data from just one port. And I had to censor the last 3 digits of the IP, so that's why it's bad. So it can be important to select which port your data is coming from. On the other hand, this is a different example. Here, the target IP is getting like bombarding just like 443, which is HTTPS. So if you're trying to have a secure connection, this is the port you'll get all of your data from. And the source IPs, they are like giving requests from different ports. So that can be also interesting because when I was trying to show the network visualization, you cannot show all of those information in just one network. It can be very distracting and non-informative. So I made like 3 different visualizations, but tell one story. Again, you can see like just sort the ports. Instead of like this one was timeline, you see like over time how it happened. And this is just like a overview, like which port got most of the denies. And thirdly, like, okay, you already know, like, okay, something bad is happening or something bad already happened, so now you go back to your system, you want to analyze the event logs. So this is one of those example event log, like what happened to your system at what time, like who attacked, or like what software or what process was executed. Sometimes it's just you, like you use a lot of software, you use a lot of applications, you will see a lot of them from yourself, and you will also see that a lot of them maybe like some other user trying to access your system. But again, like, do you actually see what's happening in this way? Maybe. I actually talk to people and they look at it like, oh yeah. I'm like, I don't know, and then it's like magical. Yes, I talked with someone today and they got to see it, like, they can tell, like, they're doing it all the way, all the time, every day. But I felt like, okay, visualization can actually make it, like, they're so smart, this can actually help them. So rather than going through this list of what happened, you actually see what happened, and it's colored by the type of event. So in this case, green is file access, so you see like P or orange is a process. So there was a process in your system, someone executed that process, and then nothing happened for a long time. And then they accessed your file, they try to run some exploit code in your system, again they access some file, again they did some API calls, so lots of other things happen in that particular time. So they were sleeping and now they're like getting active. Probably they were not very successful, so they're trying. So rather than having all those events in one line, I try to make them like stacked, just so they're not like crammed and you can actually see what happened. And if you click, then you can actually see that each event will see like what actually happened. So you click each event and you see like the details. But again, like sometimes just by looking at that pattern, you can see like, oh yeah, I think that happened, like this is the way. And then you can like details on demand, you click it and see like, oh, what process was actually executed. So this was also very well welcomed. So we're very proud of it. Like we gave it to our analysts and they're very happy that now they can actually see what's happening. So another of their suggestion was like, since we are showing the process, sometimes there are parent process. Like the web history, they wanted to see like one process called another process, so they want a link between the process. So we will give them more information, so that's coming soon or sometime. So now I'm going to like generate examples from the internet, like okay, time series of events. You can see like when you are trying to see, when you are trying to detect anomaly, you actually have to know what is normal. And then you can get to see like what is abnormal, right? So you establish your baseline. You see like, okay, this is like all the network traffic like happening. Like my network is busy this time of the day, and printer is very like random. Like definitely there is no pattern of people's printer usage other than like workday or something, work time. And people are getting their workstation also. Like most of the events are coming from people's workstation. Like people who are basically working. So it's like a detective insider threat. Like they are monitoring, like if your company wants to monitor your activity and see if there's any insider threat or not. So this one shows login attempt. This is work hour. So if someone is trying to access different parts of your office organization system, it's pretty normal. Like yeah, I will try to log into different systems. But this is like 6 a.m. and there's a high jump. Like why would someone try to access the system at 6 a.m.? So that's kind of abnormal. Maybe it's not, but then you want to see more details, like what actually happened, why they tried to do it. Maybe they're in a different time zone, or maybe, I don't know, maybe he's crazy, he wants to solve some bug at this point. So this is a way to like visually detect anomaly before your machine learning algorithm or any software can tell you like, oh, here's something problem. You can just look at it and see. Another one is like same thing, like activity. You see like here, this is normal, but suddenly there's a huge jump of activity. So maybe someone's trying to access your system again because it's like so aberrant from the normal behavior. And the second one is the opposite. Like usually your system is very, very busy, but like, hey, why is it not busy right now? What's happening? So in this case, what happened was some sensor was not working or something, so we were just not getting any data. So that's again like giving you a clue like, hey, maybe I should see my system, like, am I not giving any data because no one is generating data, or my system is just crashed and I'm not getting any information from my client. So all those visualizations can be used different time or different modes of operation when the analyst is trying to understand whether it's a threat or not. For example, contextual view. So most of the things I play, it can be like contextual view. You're already looking at a table and you want to see more, then you see a visualization. Another can be dashboard, where you see like different visualization of the same data in different modes. Multiple coordinated views comes in the same mode. I'll go in details. And situational awareness, that's more like, think about like a situation room. Like. So for dashboard, there are several data visualization software like Grafana, Kibana. They're being used from in lots of companies. Like rather than building their own software, they just have those software over their event log and then try to visualize what's happening. Like, oh, this is how the system is working, and there's like Sparkline. If you have several servers, you can see the activity of different servers, and you can compare that. Or like, hey, I have like a tiny red bar, so yeah, I have some critical alert or critical threat that I have to look into, so whether they're actually a threat or not. And then lots of like green, which is like regular traffic, this is fine. Another example was Kibana, and this one is based on Elasticsearch. So again, like your server is streaming all those events, all those data, and you're just trying to visualize like what's happening in a chart. So you see like the activity in time series, and you see which IP is sending how many packets, and again, like what are the traffic types. So you get like a immediate view of your overall system, and then you can decide like what to do next. And the coordinated visualization is more like same data, but you are sending two different visualizations that are linked. For example, this one is a network visualization, it's all the IPs, and this one is a timeline visualization. But they're same data, so if you move around the time, you see your network changing. So you filter once, another one is also filtered. Or same way, like if you click here, you see like all the nodes that are connected to this IP, and then you see like when they're active. So two different visualizations, but they're coordinated, so you can actually see like what happened in time way and what happened in the network ways. Same thing here, you see like lots of green traffic, that means like it's traffic over time, and they're like, oh yeah, they're fine, they're not dangerous traffic. But then you can also see in the lower visualizations the actual amount, rather than just over time. And like you see like teeny tiny red bars, so like those are like malicious traffic, and you also see the total size of those type of malicious traffic, so you have an overview. And you can also like filter, if you only click the green bar, all the red things go away and the yellow things go away, and in both views it's only the greens. And for situational awareness, it's more like this. So you have all those huge monitors, and they're showing like the current situation, like, hey, this network is traffic is coming, this malware is coming, you have to go and you have to run, like, oh, some system is like super compromised, you have to call the clients, like, hey, we don't know what's happening, but just shut down everything. So it's more like you have to assess the situation immediately rather than like go deep into the situation and like think what's happening. It's more like thinking with the current scenario. So these are some of the ways you can use visualization to analyze security data. I'm not done yet. Do I have time?
5 minutes.
Thank you, yeah. Or if you want to ask some question, pause. Yes, please.
Are there any metrics that you have that these visualizations have actually increased the efficiency of finding anomalies?
So, not in my team. It's more like people get very happy and crazy, like, oh yes, this is like really helping us. We don't have the exact measurement. Oh wait, let me see. Sorry. Yeah. There was this anomaly thing. Yes, this one. They actually said it basically they had no idea before using the visualization what's happening in their system, or if something is broken, they had no idea that it's broken. So it's more binary, like yes or no. So we didn't even ask them like, hey, how much time it saved, because they were like, we didn't even know that we can do it this way. So yeah, so we were very happy about that.
I have a question.
Oh yeah.
Yeah. Right. So preface. Oh God. Okay. You showed that control room. You see that in a lot of movies. You see that the DoD. The first question is, do hackers use visualization tools to counter what you guys are doing? And the second question is, how will this apply in the future when VR is mature enough where you can interact with some of those visualizations, not the pie charts and the more formal stuff, but actually, you know,
like
interact
you can
with it.
report everything.
Yeah, you can actually not only interact and rotate the visualization, do all that stuff, but actually interact with it and apply methods to counter it without using a keyboard and a mouse. So thank you.
I don't know about what hackers do, but I think they will do it. I hope. I don't know. I'm a I don't know, promoter of visualization. So if hackers do it, I'm fine with it. No problem. And for the VR, actually, some teams are using some sort of like augmented reality, not exactly
right. AR, VR.
Yeah. They made some prototype, but again, the same question: like, does it actually help or not? So maybe it does, maybe it doesn't. But so far, I haven't seen all the research have been going for like interacting with visualization this way. It's very engaging. It's very, very engaging. So that's the plus point. But like whether it tells you what you need to know, that's so far not proved. Same with 3D visualization. Like, oh, 3D, it looks very fancy.
Right.
It actually sucks. It will give you misinformation. So that's like more research to do in that arena.
Thank you.
Okay.
So the next question is, does it help you predict the hack before it's happened, or does it already have to have happened before you can do anything with it?
So there are two aspects. One is prevention, one is detection. So definitely it will help before it happened. So if you see the pattern, like, okay, using the visualization, it's really easy to see the pattern. Like, oh, it looks like it's going through a hacking direction. So you can tell your client or your customer or whoever is using the system, like, yeah, this part of the system is compromised. Like, shut it down or quarantine. So this way, but if it's already happened, then yes, you have to detect and like take future measurement.
If
but
you're quarantining
you always have to try to prevent it.
If you're quarantining it sounds like it's already happened.
It's more like blocking access to the hacker. If, like, say maybe they already have a command system established, but they still need to, maybe they try to like manipulate your system, like access it. So yes, like changing your password. Yeah. Yes.
My impression is that much of cybersecurity is checklist driven. Are the people and processes adhering to best practices or guilty of bad behavior? Do you try to do any visualization of that kind of qualitative data also, or just the machine generated data from the packets and the logs?
So far it's all machine generated data, like that I can come to, like, absolutely sure. What we also want to do is, like, when the analysts are using their system, basically store what they did and then try to automate those processes, but like, not anything about what they did. So yes, yeah. I'm almost done.
Do you have more slides?
Yeah, I have 2 more slides, which is not important. I was going to say,
This looks like a very important slide.
so that's more like a takeaway. VSEC is an awesome security conference. It's like half industry, half academia. So people from APL, JPL, FireEye, we try to write research paper based on what we do in industry with real data, but like somehow anonymize the data. So I would say, like, this is a very, very, very interesting conference to go. So if you want to submit poster or anything, I'm not related to the organization, but every time I go, I learn something. So this was more like I wanted to talk about this conference, so definitely check it out. This is one of the papers from APL, Advanced Physics Lab, something, yes. So they try to show, like, hey, this is my network, and these nodes, they have like Adobe Flash not updated. And then there's like, hey, this looks like a vulnerability. So then they try to see, like, predict the future, like what happens if I quarantine those nodes? Is my system still vulnerable or not? So it's more like a predictive visualization. And another one is from DC-based, not DC-based, like Virginia-based cybersecurity research firm. They're trying to do malware analysis, so every column is a malware. And they're trying to show, like, visualization of, like, how those malwares are related. So if you know that, like, this malware's behavior is related to this other malware, then you can recommend solutions. Like, hey, yeah, you're behaving like that other person, so this is how I blocked him, so this is how you block this other malware. Like, more like similarity-based matching. So another one was really nice. It's like using machine learning and data visualization. So using machine learning, you're predicting what is normal behavior, what is abnormal behavior, and then you see, like, hey, this looks like abnormal behavior, and then you go and check, like, why it's abnormal. So using machine learning to use, and then showing it to the analyst, and yeah, basically giving them more options. Okay, now go ahead and yes.
Thank you. The conference is in DC almost? Or?
Oh no, it's all over the country. Like, every year it's different. Mostly in USA. So far, I think it was only in USA. This year it's in Colorado. Last year it was in Baltimore.
I'd say tweet them out and mention at database.
Yes.
Yes. And if you want, like, data source, like free, open source free data for cybersecurity, the conference page has, like, a lot of them. Because no cybersecurity company will give you their data.
I'm asking if you would take all of these thoughts and tweet them with the at to the database.
Yes.
So all you have to remember is go to the database Twitter handle, and it'll all be tweeted soon.
Absolutely.
So my question is regarding the last line. A lot of what you said is the work that the cyber analyst does is predict, look at pattern. So what machine learning seems to be a very geared towards this. So it seems that visualization machine learning might be to reduce some of the tedious and.
So that's what we're doing right now. So we do the prediction first, and then because, like, there are so many network traffic, no human can look at all those traffic coming. So the learning or machine learning algorithms will say, like, this looks suspicious, look at that. So this is basically a filtering mechanism for them to look at, like, which ones looks more suspicious.
So these are built in-house at your company, or they're commercial vendors that have?
I don't know all the details, but we have an Intel team who works on that, like, generating those rules. Yeah, thank you. And yeah, so these are all the takeaways. Like you say, like, humans and machines, they work together better. And another thing is, like, I'm a data visualization person. I don't know much about cybersecurity. The cybersecurity people, they don't know about data visualization. So working as a team, it really helps. And like I mentioned before, like there is not much middle management, so you can just directly go and talk to them and like make something and go show it to them, so they're really happy. Or if it sucks, they will say like, oh, it sucks, so you can like go back and change it. So like integrating the analytics in their workflow, because they're very, I don't know, they're very used to like using command prompt. And like, oh yeah, visualization, like barely all of those, like, but you have to kind of approach them like, no, this really will help you. And like, yeah, like choosing the network layouts.
But are there any other questions from the audience? There's you covered a lot here.
Oh yeah, I was like very strict on it.
No, it's fine. It's kind of neat how you relate things, and then you realize, okay, well, I've got a hairball and I've got a centralized thing, and you kind of went through the progression. And you're like, well, now what?
Yeah.
Right, and then you start analyzing the two of them. You're like, well, okay, how do we differentiate things? You start coloring them, and then you start labeling them, and you investigate one, and you realize that it's a bait and switch, and that it's actually somewhere else.
Yes,
and,
yes.
You know,
They
so
use,
yeah.
I didn't know.
Alternative facts,
Oh, yeah.
all that stuff. But it's interesting, the progression. One last round of applause.
Thank you very much.
That does make it for tonight. Thank you all very much for coming out. I'll be leading everybody over to the bar afterwards. We do need to be out of here by 9 o'clock, but that's in like 10 or 15 minutes or so no need to rush. And we'll see you all in a few minutes.
Thank you.
Sure, gotta get back to the beer. I get it.
How's it going to the airport? I'm done. Oh.